In this video, another method of solution to the last problem posted on this channel on the 5th of November of 2020 will be discussed. For this new method, the actual force rotating the wheel and its vertical component must be calculated from the horizontal component of the force F given to be equal to 99 Newton and the value of the angle supplied. I am repeating again. For this new method, the actual force rotating the wheel and its vertical component must be calculated from the horizontal component of force F given to be equal to 99 Newton and the value of the angle supplied. So, as you can see on the board, Fs vector is the force vector inclined with the 99 Newton force at 30 degree. Please see that Fs vector is the force inclined with F vector at 30 degree. And of course, Fv vector denotes the vertical component of Fs vector. I would repeat again, Fv vector denotes vertical component of Fs vector. Now, employing very simple technique of vector analysis, it can be seen that F equal to Fs cos 30 and thus Fs equal to F sec 30, and putting values of F and sec 30, magnitude of Fs is written in equation 1. Please follow equation 1 carefully on the left hand side of the board. And the magnitude of Fb is given by equation 2, which also appears on the left hand side of the board just below equation 1. So please note that carefully also. So the force vector in three-dimensional Cartesian coordinate system is expressed as in equation 3. Please note equation 3 appearing just below equation 2. Again, using same coordinate system, the radius vector d connecting the terminal points of Fs, F vector and Fv vector to the center of the wheel C is formulated as shown in equation 4, which appears on the right side of the board. Please note equation 4 carefully. I am repeating this important part again. Using the same coordinate system, the radius vector d connecting the terminal points of Fs vector, F vector and Fv vector to the center C of the wheel is formulated as in equation 4. Here, the negative sign comes as movement is along negative y-axis as one traverses from terminal point to the point C, which is the center of the wheel. Here, the negative sign comes as movement is along negative y-axis as one traverses from terminal point to the point C, which is the center of the wheel. So, using the well-known vector definition of moment of a force given by tau vector equal to d vector cross f of s vector, that is, cross product of d vector and fs vector will give the value of the moment of the force denoted by tau, which is tagged as equation number 5, appearing on the right side of the board just below equation 4. Please see that carefully. Now expressing the cross product in determinant form, tau vector takes the form as shown in equation 6. Equation 6 is the final equation for the problem, so please look at that very carefully. And on expanding these, one easily gets tau vector equal to 6534 into root 3 Newton meter directed along the positive z-axis. That is, tau vector equal to 6534 into root 3 k cap Newton meter, which is the common unit of the moment of the force. Thus, same value of magnitude of tau vector as found in the last method is obtained. So, as expected, option C is correct, which as usually appears on the topmost left side of the board. But this method is more complete, as using this method, the direction of tau vector can also be found. I would again repeat, this method is more complete, as using this method, the direction of the moment of the force can also be found. As for example, in the present case, as has already been mentioned, tau vector is directed along k cap, that is positive z-axis. The solution has been illustrated very clearly. It is hoped that everybody who watches this video will be able to understand the solution. Thanks for watching.